Hello friends, today I'm going to solve Leetcode problem number 2483, minimum penalty for a shop. In this problem we are given a customer's string and the string consists of only characters n and y. Okay, and if the ith character is y, it means that customers are coming at ith hour, else if it is n, then there are no customers at the ith hour, and we need to close the shop at the jth hour where j is greater than equals to 0, less than equals n, and calculate the penalty for closing the shop at that given hour. And we calculate the penalty based on these two conditions. That is, if we close at jth hour, then for every hour when the shop is open and there are no customers, then the penalty increases by 1, and for every hour when the shop is closed and customers come, the penalty increases by 1. Okay, so basically what does that mean? Let's look at this example over here and try to figure that out. Okay, so let's suppose I'm closing my shop at this hour. Okay, so at index 1, so this is 0 1 2 3, so I'm closing at index 1. So if when I close at index 1, we are also given that if the shop closes at jth hour, it means the shop is closed at the hour j. So if I'm closing at ith hour, then the shop is closed at hour I, which means that shop is closed for the rest of the hours including I equals to 1. Now let's take these two conditions. For every hour when the shop is open and no customers come. Okay, so for every hour the shop is open for only 1 hour and there are customers coming, right? We have the value y, so there is no penalty. But for every hour the shop is closed and customers come. Okay, since we are closing for these 3 hours and customer is coming for this 1 hour, customer is coming for 2 hours, right? When the shop is closed, that is for hour I equals to 1 and I equals to 3, the customers are coming for 2 hours, right? So our penalty here is equals to 2 if we close at I equals to 1. Now if we what about if we close at I equals to 3? So in that case the shop is open for I equals 0 1 and 2, right? And we can see that at I equals to 2 there are no customers, so that's penalty of 1. And again for I equals to 3, when the shop is closed, there are customer coming in for 1 hour, so our penalty equals to 2 over here. So this is how we are going to find the penalty. Now what we need to return is the earliest hour at which the shop must be closed to incur a minimum penalty. Okay, so to incur a minimum penalty, all right. So things that we need to keep in mind from the given problem is, if we close at the ith hour, then the number of hours there were no customers when the shop was open. Okay, because if we are closing at ith hour, then shop was open before that hour, so we need the number of n's to calculate the penalty, and we need the number of y's, that is number of customers hours the customers came after the shop was closed, right? And shop was closed at ith hour as well, so we are going to take that hour into consideration too to calculate the y's. So given in these two ways, we are going to solve this. Basically we are going to use these to solve our problem. Okay, so the brute force would be to find the number of n's before the ith index and y for y's after the ith index, and calculate the penalty for the ith index. And we are going to do it for all the indices in the customers array. So since if we close at 0th hour, we can close at 0th hour 1 2 3, and we can close at 4th hour also, that is at the last hour after at the very end. Okay, so we can close at 4th hour as well. And the next thing is we are gonna calculate the number of ends if we ends before I equals to 0, and we are also going to calculate the number of y's. Okay, so I'm just going to take it and shift it over here. Okay, so if we calculate the number of ends before 0th index, right, zeroth index, there are no ands, right? We do not have any values, so that will be 0 by default. And now if we are going to calculate the number of ands before index 1, so what we just need to do is we need the value at the previous index, which is 0, plus the if the previous index was an n or not, and the previous index, that is 0 index, is not an n, it's a y, so that's equals to 0. So this will be equals to 0. Okay, so this means this 0 value means that all the number of ands before index I equals to 1. Okay, before index I equals to 1. So if we are calculating for index 2, we need before index I equals to 1 plus for index I equals to 1. So before index I equals to 1, we have the value 0, and for index I equals to 1, what do we have? We have y, so that doesn't add anything, there are no ands, so it's equals to 0. Now for I equals to 3, the number of ands before I equals to 2 is equals to 0 plus the number of n at index I equals to 2. So we have one n over here, so that adds to the number of ands, so we have 1 ands. Now similarly for index 4, all the values of ands before I equals to 3, which is 1, plus the value of n if we have an n at index 3, so we have a y which is equals to 0, so we have 1 over here. So these are the number of n's, right, before the given index I, right? Now similarly for y, we are going to calculate at index I and after that. So to calculate the index number of y's at index I and after that, we need the value of y's after that index, right? So that is why we are going to start from the last index, and for last index, which is at index 4, since we are closing at the very end, there are no values after that value, right, after that index, so we are just going to by default have the value 0 for I equals to 4. Now for index 3, we are going to find the number of y's after that and that given index 2, right? So y after that is 0, we take the value of y at from this index plus at index 3. So at index 3 we have 1y, so that is equals to 1. Okay, now similarly for index 2, we take the value after that, so that is 1, number of y's after that index plus number of y at this index. So since there is no y, so that will be equals to 0, so it is equals to 1. Similarly for 1, index 1, we take the value after that, which is 1 plus the value at index 1, which is a y, so plus 1, and that is equals to 2. And similarly for index 0, we take the value of y's, number of y's after that index, which is equals to 2, plus if it is y, then we add a 1, and this is equals to 3. So now that we have the number of n's and number of y's, right, the penalties for both the cases, now we take both the cases together and find the penalty, total penalty for given index. Okay, so for index 0, we have a penalty equals to 3, right? We add both the penalties. For index 1, we have 0 plus 2, which is equals to 2. For index 2, we have 0 plus 1, which is 1. For index 3, we have 1 plus 1, which is 2. For index 4, we have a value 1. So here the penalty is minimum at index 2 and index 1, but we need to find the minimum index, so that is equals to 1, and that is equals to 2, right? So this is the answer, and we are going to return this answer. Okay, but for this solution, we are actually storing the values of n and y in our array, and in that case we are using O of n space complexity, so that's adding to our space, and our time complexity is also of n, but we can actually solve it in constant space complexity and O of n time complexity. So I'm just going to show it how we can solve it in constant space complexity. So let us just try to see that solution over here quickly. Okay, so what are we gonna do is, as I already told, we need the number of ants before index I and all the values of y at and given index after index I, right? So initially we are just going to count the number of ants. Okay, so we are going to find the penalty for only ants, if that is if the shop was open and there were no customers in. So starting from that, we are just going to count. So basically we count the number of ants in this string, and the number of ants is equals to 1. Now finally what we do is this basically this is equals to the penalty of index 4, right? Because for index 4, y is always by default equals to 0, and n is basically the total number of ants before total number of ants in the string, because we are closing our shop at the very end, and total number of ants in this string gives the penalty. So basically this is equals to the penalty at index 4. So we by default result becomes equals to 4 and penalty equals to 1. Now starting from the last index, which is index 3, we start to calculate the penalty for that given indices. Okay, so since this index is equals to y, and for index 3, if we are closing at index 3, it is y, so we add to our penalty. Okay, so our penalty now becomes equals to 2 because it is y. Okay, and since this is greater value than our penalty, okay, so let us just current penalty is 2, which is greater than our penalty, so we do not change our result. Okay, next we calculate penalty at index 2. So to calculate penalty at index 2, what we do is we take the value here, which is equals to n. Okay, and since this value is equals to n, we reduce minus, okay, we reduce a 1 from our current penalty. So why are we doing that is because if you would just logically look at it, we calculate the total number of ants. Okay, this is equals to the total number of ants till this index plus the y's after this index, right? Because we had a y and we added a y to this. So now for this index we need to reduce the number of ants because we are closing at index 2. So what we do is we do a -1, so the current penalty becomes equals to 1 at index 2, right? And that's the value at index 2, the current penalty is equals to 1. Okay, so next, since our penalty and current penalty is equal to the same value, and what we need is we need the minimum index, right? And that is why what we do is we change the result, and now our result is equals to 2 because our minimum is at index 2. Next we move to index 1, and at index 1 we have a y. So since we are closing at index 1, and if there is customer coming in, which means that our penalty increases by 1, so we increase the penalty by 1. Now our penalty at index 1 is equals to 2. Similarly for index 0, we have a y as well, so we increase our penalty by 1. Now our penalty at index 0 is equals to 3. So in this way we find the penalty for each of those, and based on the penalty, if we have the minimum value, then we update our result, and finally we return the result. Okay, and that is how we can solve this problem in constant space complexity. So I hope you understood the solution. Now let us dive into coding, and let us start with n equals to customers length. Okay, so now we need the number of ants, so I'm just going to define it as penalty equals to, initially it is 0, so starting from I equals to okay, let customer of customers, and if customer that is at that index, if that value is n, then we just increase our penalty, right? penalty by penalty by 1. And now at the end we'll have the number of penalties for index last index, right? So last index we by default have the value, so let result equals to n, which is the last index, and now we need our minimum. So basically we need our current penalty, and let current penalty also be equals to penalty, because that is the current penalty. We are starting from the end. Right now let's start from n minus 1, that is from index 3 for this example. Okay, and I is greater than equals to 0, I minus minus, and what are we going to do? We are going to check if the current value is equals to y, then we add to our penalty y, because we are closing at this hour and there is a customer coming, so our penalty is increasing, right? So current penalty plus equals customers at this index. If it is equals to y, then what we do is we add a plus 1. If not, if at given index it is n, then we are going to reduce the number of n's, because n's basically do not contribute the penalty, but we were initially adding the total number of n's over here, right? So if there is n, then we have to reduce that n. Okay, so in that way we find the current penalty, and now we need to check if our current penalty is less than or equals to penalty. Why equals? Because we need the minimum earliest hour, that is the minimum index, so that will give us the minimum index, because we are starting from the last index, right? So if that's the case, then our result will be equals to the index I, and current penalty will be equals, okay, not current penalty, penalty will be equals to current penalty, and then finally we are going to return our result. Okay, now let's try to run our code and check if this one works fine. Awesome, I have added few test cases of my own just in case. Okay, let's submit this one. Great, so we are able to solve it in constant space complexity and O of n time complexity. Okay, I have also solved this problem in using O of n space complexity. So if you just want to go over this solution, I have it on my link Leetcode profile. Just have a look, and I hope you like my solution. Let me know in the comments down below. Thank you so much for watching till the end.